between elastic and inelastic collisions. Right, and we're going to keep doing that for the next, certainly for the next class after today as well. All right, so disclaimer. What does that mean, disclaimer? Warning. It's not really a warning. It's like what I'm about to tell you comes with some baggage. Right? What I'm about to tell you comes with some caveats. So I'm going to talk to you about a couple different, 2.5 different kinds of collisions today, but I'm not giving you like official definitions of those collisions. Yeah, sorry, Brady. We're going to be more specific, more precise in the coming chapters, right? So what I'm telling you today isn't false, it's just not the entire story. So we do have 2.5 different ways today that things can collide, right? We're just going to stick with 2 object collisions. One way that they can collide is elastically, or they could have an elastic collision. So one of the ways that distinguishes an elastic collision from the other type is that we generally have like a bounce, and neither of our things that are colliding get permanently deformed or messed up at all. Right, so let me show you an example of an elastic collision. Maybe we'll look at a couple other examples as well. But I just have a very brief video clip of a tennis ball colliding on, or dropping onto a tabletop or something. And to me that looks like a bounce, right? We don't usually see bounces all that slow, but it looks like a bounce. And does anybody see obvious evidence of permanent deformation or damage? Anybody see obvious evidence? Yeah, me neither. Right, so that would be a pretty decent example of an elastic collision. Let's contrast that with an inelastic collision. So in an inelastic collision, we probably don't have a good bounce, but something gets messed up. Something gets some more than temporary deformation or gets damaged. It doesn't look the same after as it did before. So this next video is a small clip from like a 9-minute long video. If we finish our lab early, I'd be excited to watch all 9 minutes. If we don't finish early, you might choose to watch this at home. But this is a video of some guys like dropping things 4 stories onto a sidewalk. So and within the first 30 seconds, they just give us some previews of some of the things that they'll be dropping. And hopefully we'll see some pretty obvious evidence of damage deformation. Right, these things are not going to look the same after as they did before. So anyway, they show way more than those things, and they show us the whole drop, but all of those would be examples of inelastic collisions. It's actually a good video. They bring in a physicist to do some terminal velocity calculations and then help them drop some of those things. All right, so we have elastic collisions, which end up not permanently deforming things, and inelastic collisions, which do permanently deform things. Questions about either of those 2 types of ways that things can collide? All right, so let's look for a few additional examples. I'm going to drop the duct tape onto the desk. Guesses. Let's see it again.
Elastic.
I'm hearing both answers, and I can understand why I'm hearing both answers. Nothing looks too messed up. It's not obvious that something got severely destroyed. It also wasn't obvious that it bounced very much, right? So maybe not so clear. Maybe not so clear. I might want to inspect this pretty closely before it fell, and then afterwards, and see if there's like some denting or anything that doesn't undo itself. Hello, Mr. Pincus. Okay. Yeah, I saw that. Nah, we'll wait till brackets are good. All right, thanks. Bye. All right, what year ride is here? So we said we had 2.5 types of collisions, right? So we've seen 2 so far. The half is one way that things can inelastically collide. So we have a subtype of inelastic called perfectly inelastic. And we know that things have a perfectly inelastic collision if they stick together. Right, like Jocko earlier in the period, right? He and the ball stuck together, so that would have been an example of a perfectly inelastic collision. So we'll see examples of all 3 of these types of collisions over the course of the next couple of classes. I have one final video that I'm not telling you what it is, and I'd like you to attempt to determine what you think it is. It's another kind of slow-mo video. Alright, so let's see what we think this one is. So this is a golf ball hitting a wall. Or maybe a tabletop, I don't know. Bye-bye. Isn't that crazy how much it deforms by? And we don't get a great look at after the collision, but it stops once the collision's just about done. I don't know what that means. Yes.
Wait, that was a golf ball?
That was a golf ball.
I was thinking, like, it's like flat. No.
How is it flat?
Why is it?
Did it get shot by like a
No, it's just hitting against the wall.
What?
What is that?
Pencil rubber.
I don't believe it.
Is
You
it?
might call that elastic behavior. That's why a golf ball is made how it's made, right? To be able to change shape so much so that it can gain lots of momentum when it collides with things. I don't see any evidence of permanent deformation. There's severe temporary deformation, but the golf ball does pop back to its regular shape. I don't know that we see it in its final regular shape, right? If they kept playing it for another 100th of a second, it would probably pop back to its regular shape. But I'm confident that is an elastic collision. We can have temporary deformation. We need permanent deformation in order to call it inelastic.
How long was it this in real time?
I have no idea how long it was in real time, but this is super slow-mo, so a super small amount of time. All right, so those are our 2.5 types of collisions. Again, there's a little bit more to the story that we're not seeing today. And in fact, we won't really see that until probably right after the midterm is my target to make those types of collisions more concrete. All right, so let me stop filming. That's the only stuff that I wanted to get to Alec and Saketh. And then what